NVMe versus solid-state drives versus hard drives. This video about NVMe versus solid-state drives versus hard drives is a test of speed between the three drives. The hard drive is an ordinary Samsung mechanical type, a few years old but typical of most hard drives. The solid-state drive is a Crucial BX500 SATA drive and the NVMe is the reasonably priced Crucial P3. A bit about the background of these types of drives. The hard drive. I can remember when the first hard drives became available for home computing. Before this, data was stored on floppy disks. Originally they were 5¼ floppy disks. You had loads of them and they were slow. The traditional hard drive is a mechanical device. It writes data to a metal disk using magnetism, so it's not unlike the old videotape recorders. Because it has a disk that spins and the head writes, there is a limit to the speed you'll ever get one to work because of the technology. That's been pretty much reached in the last few years, so the days of traditional magnetic mechanical hard drives being able to work quicker have gone. If you are considering replacing a hard drive, you may want to consider a solid-state or M2 drive. The solid-state drive. The solid-state drive doesn't have any moving parts at all. It's entirely electronic, and this means not only it is lighter but uses less power, it is also a lot faster. The solid-state drives that most people are aware of are similar in shape to the 2.5-inch hard drive. This was because they were intended to replace the old hard drive. This was by just plugging into where the old one went. Originally these hard drives had the IDE interface, and you may still encounter this on older motherboards with this type of interface. However, the IDE interface has been replaced by the SATA interface. The SATA interface was designed while hard drives were still being used. The SATA interface can transfer data at about 600 megabytes a second. The old hard drives couldn't transfer data at this rate. The problem is that the solid-state drives are limited by the SATA interface. You can make an SSD as fast as you like, but as long as it uses the SATA interface standard it won't matter, because it will always be limited to 600 megabytes a second. M2 drives. The M2 drive is a solid-state drive that is more like a card than a drive. It's also a lot smaller and you can get various sizes. If you have an M2 SATA drive it will still be limited to data transfer rates. This is the maximum of 600 megabytes per second because of the SATA interface. This is where the M2 NVMe drives come into it. You can get M2 drives with an NVMe interface instead of SATA. They look very similar, but if you look carefully at the connector you'll notice that the SATA M2 connector has two cutouts, or keys as they are known, whereas the NVMe M2 card has one cutout or key. The NVMe interface can transfer data at up to 3,500 megabytes a second, so if you do the math that's about 6 times faster than the SATA solid-state drive. The speed difference. It can be quite difficult to measure disk speeds because there are various things that you can measure just about speed. So which ones do you choose? There is read speed, write speed, sequential or random, and then there is the size of the data that you transfer. In the end, it can be very confusing trying to look at all the different combinations. Although there are variations between types of technology, a fast drive is faster at most of the different types of transfer than a slow drive. I used the Crystal Disk Mark software for the test. The hard drive reached a read speed of 138 megabytes per second. The SATA solid-state drive reached a speed of 547 megabytes per second and the NVMe solid-state drive reached a blistering speed of 3,484 megabytes per second. I've also used the Mini Tool Partition Wizard. This software has various tools for configuring disk partitions and it also contains a disk benchmark utility. There are many things you can configure and test, but for most people, you just want to be able to compare disk speeds, so I've just used sequential reading and writing at 4 different sizes. These are 4K, 8K, 16K and 32K, and these settings are the same across all of the disk tests to get a comparison. The figures are in megabytes per second. It's interesting to look at actual figures that a real system achieves rather than quoted speeds in theory. As you can see from the figures I got from the test, the SATA solid-state drive is about 4 times faster than a mechanical hard drive. That's quite a speed increase, but then just look at how fast the NVMe solid-state drive is. It's over 6 times faster than a SATA solid-state drive, in this test, and around 25 times faster than the original hard drive. These are impressive speed increases and I'm quite happy considering I've just invested in the NVMe drive.